Right, let's carry on with this light worksheet. So refraction is what? Is the change in direction of waves at a boundary. So refraction is where the wave changes direction at a boundary. Right. The ray coming in is called the incident ray. The normal is perpendicular or at right angles to the boundary. And the angle of incidence is measured from the incident ray to the normal. The ray that's refracted or that bends is called the refracted ray, and the angle of refraction is between that ray and the normal. Right, you have a refractive index is how much a material bends light, and it's calculated using, it's got the symbol N and it's sine I over sine R. Again, in 2024 you're going to be given a sheet. Right, what are the two types of wave? Longitudinal wave and a transverse wave. A longitudinal wave, the particles vibrate along the direction. So if the particles are vibrating that way and the waves traveling that way, it's a longitudinal wave. And transverse waves are waves where the vibration is perpendicular or at right angles to the direction of travel. These definitions, you might as well just learn them word for word. They're just useful. Right, and then finally, total internal reflection occurs when the angle of incidence, this angle here, is bigger than a angle called the critical angle. So this angle here, if it's bigger than the critical angle for that material, you're gonna get total internal reflection, and it only happens when the ray, so it won't happen here because you're going from an optically less dense material to an optically more dense, which is the glass. If the ray was coming in this way, it would bounce off. Right, the electromagnetic spectrum, you've got radio waves, microwaves, infrared rays. Radio, micro, infrared. I can't remember a mnemonic. It's just doing my head in. There was something. Radio has got the longest wave. Gamma rays have got the shortest wave, highest frequency. So radio wave, microwave, infrared. Then you've got visible light, and that can break down into Roygbiv, ROYGBIV. Then you've got ultraviolet, X-ray, gamma. Ultraviolet, X-ray, gamma. Okay, leave it like that. Let's move on. Right, let's keep moving on. Where was the question? Right, we're looking here now. What's going on here? Right, a student is listening to radio. The radio is powered by batteries that provide DC current. Right, what is direct? What's this doing here? Okay, it doesn't matter. Let's live with that. Current that moves in a single direction or one direction. It only goes in one direction. It doesn't go backwards and forwards. Gives a steady output. Radio waves are part of the electromagnetic spectrum, suggest the property of radio waves that make them suitable. They travel quickly. They travel quickly at the speed of light. Right, what else is there? They're not harmful. unlike microwaves that are used in communication, which can potentially cause harm. You can use them over long distances, long distance communication. You can code information on them. That's it. Right, any one of those. Right, complete the table to show the uses and possible harmful effects. Right, microwaves are used for communication and cooking. Communication and cooking. What are the harmful effects? They can cause skin cancer if you're exposed to a lot of it. They can cause sunburn, and they can damage your eyes, the retina, damage eyes. Right, ultraviolet is used for, it's used for tanning. Maybe not. Right, okay, it's used for fluorescent lamps. I know that. Fluorescent. Used for fluorescent lamps. It can be used to kill bacteria in filters. So kill bacterial microorganisms, or it's called stick to bacteria. Bacteria. Right, what are the possible harmful effects? Again, it can cause oh, right. I don't like this. Microwaves can damage the skin, but the problem that you're going to get with this is it can cause the effect of heating. I've got to be careful with that heating. Skin cancer, eye damage, sunburn. Yeah, so ultraviolet. That's what I thought it was. It's used for, what do they call them? Tanning lamps. I thought they were used for that. Tanning lamps. If you've got too much exposure, it can burn you. It can cause skin cancer, and if it hits your eyes, it can cause damage to the retina, cause blindness in effect. Why is this sound weird? So this is light. This is not. Actually, do you know what we'll do is we'll include this, because no, let's leave it. Let's just leave it. Let's just leave it. Right, okay. The Earth receives different types of electromagnetic electromagnetic waves from the sun. Right. Infra, ultra, and visible. Right. Let me just go get that diagram. Right. Let's see if we can. There you go. Go back, Where are we? Right. So you've got infrared is here. Yeah, and then you've got visible light in the middle. Where are we? Visible light here. Oh, come on, it's playing up again. Just bear with me 1 second. Right. Let's see if it's right. Sorry about this. Right, okay, look. What happens is when I try to draw and pick a colour, it doesn't like behaving. Okay, now it's behaving. Good. Right. So we've got visible light, and then we've got ultraviolet light. This is long wave, this is high frequency short waves. Complete the table by arranging these types of electromagnetic wave in the order of decreasing wavelength. Okay, that's fair enough. So what we can do is we can say this is the longest infrared, then you've got visible, and then you've got ultraviolet, shortest wavelength. So remember, it's radio waves, microwaves, infrared waves. Then you've got light, ultraviolet, X-ray, gamma. Name two other types of electromagnetic waves. So we've got them here. We can say radio and micro. And microwaves. It's weird, isn't it? How you've got to put wave in front of radio and micro, but not in front of infra, ultra, X ray or gamma ray. Those are rays. That's fair enough. Right, okay. Ultraviolet waves are useful, but they can be dangerous. State two uses of ultraviolet. Ooh, okay. What did we say? It was to do with ultraviolet is used for killing bacteria. Fluorescent lamps. Fluorescent lamps. This is where you in tanning places. And that's for making things sterile. What are the two dangers? Ooh. What are the two dangers anyway? It can cause skin cancer, and it can damage the eyes, can damage the retina, can damage eyes, and it can cause burns. Right, okay. So remember, that was very similar to, just to show you, look, it's the same thing, just keeps repeating itself. Right, okay. Let's have a look. Right, what we'll do is we'll call it quits and put that other one on the next video. Just shorter ones, I think, are better format.